In question 1, a curve is such that its gradient at a point is given by dy dx, x minus 3, x minus half. It is given that the curve passes through the point 4 and 1. We have to find the equation of the curve. Now, to find the equation of the curve, we'll have to integrate the expression for dy dx. So that is x minus 3x to the power minus half. So now integrating both the sides, and we'll be taking the dx on the right-hand side. So we can first make it mathematically correct. So this will become dx. So when we integrate dy, that will become y is equals to integrating x. So that will become x squared upon 2 minus, this will become 3x to the power plus 1 upon 2, and we'll divide it by the new power, which is 1 upon 2, and we'll add a constant. We can simplify this to write it as y equals to x squared upon 2 minus 6x to the power 1 upon 2 plus c. Now, as the curve is passing through the point 4 and 1, we can substitute these values to find the value of c. So y is 1, x is 4, so this will be 4 squared upon 2 minus 6 into 4 to the power 1 upon 2 plus c. So this will be 16 upon 2, which is 8. So that will become 8 minus, this will become 6 times 2, which is 12 plus c. 8 minus 12, that's a minus 4 plus c. So c will be 1 plus 4. The value of c will be equal to positive 5. Once we have the value of c, we can write the final equation as y equals to x squared upon 2 minus 6x to the power half plus 5. In question 2, the circle with equation x minus 3 whole squared plus y minus 5 whole squared equals to 40 intersects the y-axis at points A and B. We have to find the y-coordinates of A and B expressing our answer in terms of surds. Now, intersects the y-axis means we can substitute x equals to 0. So this equation will now become 0 minus 3. So we can just write when it is a y-axis, the coordinates are basically 0, comma y. So x is equals to 0 plus y minus 5 whole squared equals to 40. So this will become plus 9 plus expanding this, we'll get y squared minus 10y plus 25 equals to 40. Simplifying, we'll get y squared minus 10y. 25 plus 9 is 34. So that will become a plus 34, and this will become a minus 40. So this will become y squared minus 10y. Or we can, as we have to give our answer in terms of surd, what we can also do is we can leave y minus 5 whole squared as it is, and we can take the square root. Taking the positive 9 on the right hand side, we'll get y minus 5 whole squared. So this will become 40 minus 9, and this will be y minus 5 whole squared equals to, so that will be equals to 31. Taking the square root of 31 or on both the sides, we will get y minus 5 is equals to square root of 31. So square root of 31 can both be plus minus. So the y coordinate will be square root of 31 plus 5. So we can, let's say that is the y coordinate of A, and the y coordinate of B, that we can take it as minus square root of 31 plus 5. In part B, we have to find the equation of the circle which has AB as the diameter. Now for AB as the diameter, we know that the equation of a circle is given by the formula x minus a whole squared plus y minus b whole squared equals to r squared. Now as AB is the diameter, we know that the x coordinates of A will be, so that will be 0, comma, and we can take that as 5 plus root 31. And the coordinates of B will be 0, comma, 5 minus root 31. So we can, to find the radius, we can find the distance of AB first. So AB will be equals to square root of x2 minus x1, that will be 0, and y2 minus y1, so that will become 5 minus root 31 minus 5 plus root 31, and this will be whole squared, and x is obviously 0 squared, so we can leave it as it is. So expanding this, we'll get 5 minus 5 will cancel out. This will become square root of, so doing the proper working, this can be written as minus root 31, and this will be whole squared. 5 minus 5 will cancel out. So we'll get minus 31 minus root 31, that will become minus 2 root 31, and that will be whole squared. So 2 squared is 4, and 31, when we multiply the root by a whole square, so that will become just 31. So the final answer for this will become 4 into 31, and that will basically be the diameter. So 4 into 31 is So multiplying 4 into 30, that is 120, that will become 124. And dividing it by 2, so that will be equals to 62. Now, for the equation of a circle, we also need the center point. So the center point will be the midpoint. The x coordinate will be 0. And for the y coordinate, again, we have to add these two and then divide by 2. So finding the midpoint of AB, the x coordinate will be 0 and the y coordinate will become 5 plus root 31 minus or 5 plus 5 minus root 31 upon 2. So root 31 will cancel out. 5 plus 5, that is 10. And 10 upon 2 will become 5. So that will be 0, 5. So once we have the center point, we can write the equation as x minus 0 whole squared, which will just be x squared plus y minus 5 whole squared is equals to r squared. So the value of r will be equals to, so the value of r is 32, is 62. So that will become 62 whole squared. Just a final correction over here. This will, the distance is x2 minus x1 whole squared plus y2 minus y1 whole squared. So y2 is 5 minus root 31 minus 5 plus root 31. So this will be minus root 31 plus root, or this will become a minus root 31. So we'll get, just using a calculator for this, just a moment, just to make sure that the radius is correct over here. We'll have, so this is minus root 31 and we'll subtract it from minus root 31 again. That is minus 2 root 31. So that will basically be, okay, so there's a small correction over here, even though this was correct. This was minus 2 root 31 whole squared, and there was a square root over here, so that would have cancelled out. So the diameter over here would have become, okay, when we whole square this, so that will become 4, positive 4 into 31, and we'll have to again square root it, so that will become 2 into 31. So 2 into 31, that will become 2 into, so this, okay, I'm really sorry for this, but the correct radius in this case will become, it was minus 2 root 31 whole squared, and there was a square root over this as well. So this would have cancelled out basically. And dividing this by 2, so the diameter over here is minus 2 root 31 whole squared, and there's a square root over here. So if you multiply, this will become 4 into 31 square root, which is basically 2 root 31. And if we divide it by 2, so that will become root 31. Okay, so the radius is basically root 31 over here. So r squared will basically be root 31 whole squared, as the equation is r squared. So the final equation will just become x squared plus y minus 5 whole squared, and that will be equals to positive 31 only. So the final equation is x squared plus y minus 5 whole squared equals to positive 31. In question 3, we have to show that the equation 5 cos minus sine tan plus 1 may be expressed in the form a cos square plus b cos plus c equals to 0, where a, b, c, and are constants. So to get converted to cos form, we can write it as 5 cos minus sine, and the tan can be written as sine upon cos plus 1 equals to 0. Taking the LCM, we'll get 5 cos squared, as the denominator is 1 over here. So this will multiply by cos, minus sine squared plus 1 upon cos equals to 0. The identity for sine squared is sine squared plus cos squared is 1. So sine squared will be equals to 1 minus cos squared. So we can write this as 5 cos squared minus, this will become 1 minus cos squared plus 1 equals to 0. It is very important to put this bracket, as when this negative multiplies, this will become a plus cos squared. So simplifying this, we'll get 5 cos squared, and this cos multiplies by 0. So that will be a 0. Plus cos squared, and this will become, so this one should have multiplied by cos, so this would have become cos over here. So 5, so this will be a plus cos, equals to 0. So we'll get 6 cos squared plus cos minus 1 equals to 0. So the value of A will be 6, the value of B will be 1, and the value of C will be minus 1. In part B, it says, hence solve the equation 5 cos minus sin 10 plus 1 equals to 0. We know it can be written as 6 cos squared plus cos minus 1 equals to 0. First, we can factorize this by middle term breaking. So we can use 3 and minus 2 equals to 0. Taking 3 cos common, this will become 2 cos plus 1. Taking 1 common, we'll get 2 cos plus 1 equals to 0. Simplifying, we'll get 3 cos minus 1 and 2 cos plus 1 equals to 0. Finally, we can write cos theta will be equals to 1 upon 3 and cos theta will be equals to minus 1 upon 2. First, finding the basic angle in both the cases, so we'll take cos inverse of, so taking cos inverse of 1 upon 3, that is equals to 1.2309. And we can just leave it as 1.23, and taking cos inverse of 1 upon 2, so taking cos inverse of 1 upon 2, that will be pi upon 3. Now, once we have these basic angles, to find the values of theta from 0 to 2 pi, so in the first case, as cos was positive, so we'll take the basic angle in the positive quadrants of cos. So the positive quadrants of cos are the first quadrant, so we'll make 1.23 the basic angle over here, and in the fourth quadrant. So the values of theta which are taken anti-clockwise from the x-axis, so the first value of theta will be 1.23. The second value will be, so that will be 2 pi minus 1.23. And over here for the basic angle, as cos is negative, so we'll have to take cos in the negative quadrants, and we know that cos will be negative in the second and the third quadrant. So making pi upon 3 over here and in the third quadrant. So the values of theta now will be, so this will be pi minus pi upon 3, and this will become, so this will become pi plus pi upon 3. So the values of theta will be 1.23. So 2 pi minus 1.23, that will be equals to 2 into pi minus 1.23, which is equals to 5.053. So we can just leave it to 5.05, three significant figures. In this case, one of the values is pi minus pi upon 3, that will become, so pi minus pi upon 3, that is equals to 2 pi upon 3. And the last value will be pi plus pi upon 3. So theta, which is pi plus pi upon 3, that will be equals to 4 pi upon 3. So the four values of theta will be 1.23, 5.05, 2 pi upon 3, and 4 pi upon 3 radians. In question number 4, in part A, it says expand the following in ascending powers of x up to and including the term in x squared. So we know that the expansion formula for 1 plus b to the power n, that is 1 plus nc1 b to the power 1 plus nc2 b to the power 2. As we just have to go up till x squared, so we'll just expand it up till nc2 b power 2. Expression is 1 plus 2x to the power 5. So this will become 1 plus 5c1. B is 2x, so that will be 2x to the power 1 plus 5c2, and that will be 2x to the power 2. Simplifying, we'll get 1 plus 5c1, which is 5 into 2, that will become 10x. 5c2 is 10, and that will be 10 times 2 square, which is 4, so that will be 40x squared. In part 2, we have to expand 1 minus ax. So for this expression, this will be 1 plus nc1, so that will be 6c1 into minus ax to the power 1 plus 6c2 into ax to the power, and that is a minus, so we can take minus ax to the power 2. 6c1 is 6, so this will become 1 minus 6ax. 6c2, so that will become 15. So this will be plus, as minus a squared will, negative sign will cancel out. So we'll get plus 15 a squared x squared. In part B, it says in the expansion of 1 plus 2x power 5, 1 minus ax power 6, the coefficient of x square is minus 5. We have to find the possible values of a. So we can first write the expansions together. So that is 1 plus 10x plus 40x squared. And the expansion of 1 minus ax power 6 was 1 minus 6ax plus 15a squared x squared. Now to get the terms in x squared, we'll have to multiply 1 with 15a squared x squared, so that will become 15a squared x squared. So 1 is multiplying by 15a squared x squared. 10x will multiply by 6ax to give us a term in x squared, so that will become minus 60ax squared, and 40x squared will multiply by 1, so that will become a plus 40x squared equals to, and the coefficient, the answer is minus 5, so that will basically be equals to minus 5x squared. So taking x squared over common over here, we'll get 15a squared minus 60a plus 40 is equals to minus 5x squared. Now we can compare the coefficients. So the coefficients will become 15a squared minus 60a plus 40 is equals to minus 5. Bringing the 5 on the left hand side, we'll get 15a squared minus 60a plus 40 plus 5, that will become 45 equals to 0. We can divide the whole equation by 15 and write it as a squared minus 4a plus 3 equals to 0. Factorizing this, we'll get a minus, so we need a 3 when we multiply, so that will become a minus 3 and a minus 1 equals to 0. So the values of a will be a equals to positive 3 and a equals to positive 1. In question 5, the first, second, and third terms of a geometric progression are 2p plus 6, 5p, and 8p plus 2 respectively. In part A, we have to find the possible values of the constant p. Now, when it is a geometric progression, the common ratio is given by dividing the two consecutive terms. So we can divide the second term by the first term, and that will be equal to if we divide the third term by the second term. In this expression, the second term is 5p, so we can write it as 5p divided by the first term, which is 2p plus 6. And that will be equal to the third term, 8p plus 2, divided by the second term, that is 5p. So cross multiplying 5p times 5p, that will become 25p squared, and 2p plus 6 will multiply by 8p plus 2. Expanding the bracket on the right hand side, so this will be 25p squared is equals to 8 times 2 is 16, so that will be 16p squared. 2p times 2, that will become 4p. 6 times 8 is 48, so that will be 48p plus 6 times 2, which is 12. Taking the right hand side on the left hand side, so this will be 25p squared minus 16p squared, that will become 9p squared. 4 plus 48 is plus 52. Bringing it on the right hand side, that will become minus 52p. And bringing 12 on the right hand side, that will become minus 12 equals to 0. Now we can use our calculators to find the value of p, or we can use middle term breaking. So 9 times minus 12 is 100 minus 108. So we can use minus 54p plus 2p minus 12 equals to 0. And this is a 9p squared. Now we can take 3p common over here. So if we take 3p common on, or we can take 9 common over here, as 54 divided by 9. So taking 9p common, this will become p minus 6. And taking 2 common over here, we'll get p minus 6 equals to 0. Simplifying, we'll get p minus 6 and 9p plus 2 equals to 0. So the values of p will be equals to positive 6 and p will be equals to negative 2 upon 9. In part B, it says one of the values of p found in A is a negative fraction. So that will be minus 2 upon 9. We have to use this value of p to find the sum to infinity of this progression. So the sum to infinity of a geometric progression is given by a upon 1 minus r. So a was 2p plus 6. So as a is 2p plus 6, we can substitute the negative value of p, which was minus 2 upon 9. So that will become 2 into minus 2 upon 9 plus 6. Simplifying, we'll get minus 4 upon 9 plus 6. Taking the LCM, so this will multiply by 9. So that will become minus 4 plus 6 times 9 is a 54 upon 9. So the value of a will be 50 upon 9. And to find the common ratio, we'll divide the second term with the first term. So the common ratio in this case will be, the second term was 5p. So that will become 5 into minus 2 upon 9. And that will divide by the first term, which is 50 upon 9. Simplifying this, we'll get minus 10 upon 9 multiplied by 9 upon 50. 9 and 9 will cancel out. So we'll get minus 10 upon 50, and we can simplify to write it as minus 1 upon 5 as the value of the common ratio. Now, as we have the value of a and r, we can substitute this into the formula now. So the value of a is 50 upon 9, and this will divide by 1 minus the common ratio which is 1 upon 5 minus 1 upon 5. So the denominator will become 50 upon 1 plus 1 upon 5. Taking the LCM in the denominator, that makes it 5 times 1, 5 plus 1, 6 upon 5. And finally simplifying this, so the 5 will go into the numerator and multiply by 50. So that will become 250 upon, so that will become 250 divided by, so that is 6 upon 5. So that will become 250 upon 6. Dividing this by, simplifying this now, so we'll get, okay, and just a small correction over here. The value of A was 50 upon 9. So this 9 will also be in the denominator. So this will multiply by 9 over here. So this will be 250 as there was a 9 over here. So this would have been 9 times 6 upon 5. So 5 will go into the numerator. That will become 250 upon 54. And we can cancel this over here. This will become 125 dividing by 2. So the final answer for the sum to infinity will be 125 upon 9 times 3, which is 27. In question 6, a line has equation y equals to 6x minus c and a curve has equation y equals to cx squared plus 2x minus 3, where c is a constant. The line is a tangent to the curve at point P. So we have to find the possible values of c and the corresponding coordinates of P. Now, whenever we have an unknown constant and there's a quadratic equation, so that means we'll have to use the b squared minus 4ac, the discriminant, and as it is a tangent, there's only one point of intersection, so that will be equals to 0. Now, equating the two equations, we'll get the equation of the curve is 6x squared plus 2x minus 3. We will equate it to the equation of the line, which is 6x minus c. Bringing 6x minus c on the right hand side, that will become cx squared plus 2x minus 6x minus 3 plus c equals to 0. Simplifying this, we'll get cx squared, so that will become minus 4x minus 3 plus c equals to 0. So the coefficient over here of x squared is c, so the value of a will be c. The coefficient of x is minus 4, so b will be minus 4, and the constant term is minus 3 plus c. Now substituting this in b squared minus 4ac, so that will become b is minus 4 whole squared minus 4 into a, which is c, and c, which is minus 3 plus c equals to 0. Expanding this, we'll get 16 minus, so minus 4c times minus 3, that will become a plus 12c, and minus 4c times plus c, so that will become minus 4c squared equals to 0. Rearranging this, we can write this as 4c squared minus 12c minus 16 equals to 0. And we can now divide this equation by 4 to write it as c squared minus 3c minus 4 equals to 0. Factorizing this, we'll get c minus 4 and c plus 1 equals to 0. So the two values of c will get are c equals to positive 4 and c equals to negative 1. Now for these values of c, we have to find the corresponding coordinates of P. Now the simplified equation we got was cx squared minus 4x minus 3 plus c. So in that equation, first we'll substitute c is equals to 4, as we had solved the equation simultaneously and c was an unknown. Now using the values of c, that is 4, so we can write this equation. So let's write the equation first. That was cx squared minus 4x minus 3 plus c. So this will become 4x squared minus 4x and minus 3 plus 4 equals to 0. Simplifying, we'll get 4x squared minus 4x minus 1, or this will become a plus 1 equals to 0. Now to find the values of x, we can do middle term breaking. So this will become 4x squared minus 2x plus 1 equals to 0. Taking 2x common, we'll get 2x minus 1. And taking 1 common, we'll get 2x minus 1 equals to 0. Simplifying, this will become 2x minus 1 into 2x minus 1 equals to 0. So the value of x will be 1 upon 2. Once we have the value of x as 1 upon 2, using this value of c as 4, we can find the y coordinate. So the equation of the line was y equals to 6x minus c, and the value of c is 4, so that will become minus 4. Substituting x equals to 1 upon 2, so that will become 3 minus 4, which is minus 1. So one of the coordinates will be 1 upon 2 comma minus 1. And now using the value of c, which is minus 1, for the same equation, so that will become minus x squared minus 4x, and minus 3 minus 1, that will become minus 4 equals to 0. We can make the x squared term positive and write it as x squared plus 4x plus 4 equals to 0. Factorizing this, we'll get x plus 2, and so both will be x plus 2 and x plus 2 equals to 0, as we need 4 when we multiply and 4 when we add. So the x value in this case will be x equals to minus 2. For this value of x, to find the y value, now we can use the equation of the line, which was 6x minus c. And as it was minus c and the value of c is minus 1, so that will become 6x plus 1. Now substituting x equals to minus 2, so that will become 6 into minus 2 plus 1, which is y equals to minus 12 plus 1, which is minus 11. So the other coordinate of p could be minus 2 comma, and this is a minus 11, so that will be minus 2 comma minus 11. In question 7, the function f is defined by f of x equals to 1 plus 3 upon x minus 2 for x greater than 2. We have to state the range of f. Now for the range of f, as the value of x is greater than 2, it means that for whatever value of x that we assume over here, that is which is greater than 2, so this denominator can never be negative. So let's say we take x as 2.01 minus 2, so that will become 1 plus 3 upon 0.01, which basically means that f of x will always be 1 or greater. So whatever value of x we substitute over here, this whole function can never be negative or can never be less than 1, as it will be 1 plus a value, and this value can never be negative, which means that f of x will always be greater than 1. In part B, we have to find an expression for f inverse of x and then state the domain of f inverse. So for f inverse function, we first write y in place of f of x. Then we exchange the values of x and y. So this can be written as x equals to 1 plus 3 upon y minus 2. Taking 1 on the right hand side, that will become x minus 1 is equals to 3 upon y minus 2. Now, there are two ways we can go about this. We can bring the y minus 2 on the right hand side, multiplying, and write it as 3 upon x minus 1. And then take 2 on the right hand side. So this will be 3 upon x minus 1 plus 2. What we could have also done was cross multiplied and then made by the subject. It would have been correct in both cases. So f inverse of x will be is equals to 3 upon x minus 1 plus 2. And for the domain of f inverse, it will be the same as the range of f of x. So the domain of f inverse will be x is greater than 1. The function g is given as 2x minus 2 for x greater than 0. We have to obtain a simplified expression for g f of x. So g f of x basically means in place of, in g of x is replaced by the function f. So for g f of x, we can write it as 2 into the function f, that was 1 plus 3 upon, so that was 1 plus 3 upon x minus 2. And this is a minus 2 already in the function g of x. Now multiplying this by 2, this will become 2 plus 6 upon x minus 2 minus 2. So this 2 and 2 will cancel out. So g f of x can be written as 6 upon x minus 2. In question 8, the diagram shows part of the graph of y equals to sine a into x plus b, where a and b are positive constants. In part A, we have to state the value of a and one possible value of b. Now, to understand this, first we need to know that if we have a graph of, let's say, y equals to sine of 2x, that would mean it will have two revolutions in 360 degrees or 2 pi radians. In this case, we have our angle in terms of radians. So 2x will mean there will be two revolutions of a sine graph in 2 pi radian. So just to show an example over here. So we'll have two revolutions of sine in 2 pi radian. So 2 pi will be up here and we'll have two revolutions. Now in this case, if you look over here, this is basically ax, and we have to find the value of a. Now if we see from this point up till this point, we can see there is half a revolution. Now for half a revolution, the total angle, if we add the angle, so this from 0 till 5 upon 3, that is 5 upon 3 pi. So this will become 5 upon 3 pi plus, and this will be taken as 1 upon 3 pi, ignoring the negative sign. It means in 6 pi upon 3, or let's say 2 pi radians, in 2 pi we are having half a revolution, which means that in the value of A will be equals to 1 upon 2. As this value represents the number of revolutions in 2 pi radians, in this case, we are getting half a revolution, so that will become 1 upon 2. B represents basically a translation in the x direction. Now, looking at the graph over here, we can see that this point has moved. Initially, the sine graph starts from 0, but in this case, it is starting from minus 1 upon 3 pi. So the value of B basically will be positive 1 upon 3 pi. Now, once we have these values, we can also confirm whether our value is right or wrong. So what we can do is just assume a value of x on the graph. So let's say we take the value of x as 2 upon 3 pi. So we can just substitute y is equals to sine of a. So a is 1 upon 2. And the bracket, the value of x we are assuming is 2 upon 3 pi. Plus the value of b is 1 upon 3 pi. Substituting this in the calculator, we should get where the value of y is equals to 1. So if y is 1, it means that the values of a and b are correct. Now substituting this in the calculator, sine of 1 upon 2 into bracket 2 pi upon 3 plus pi upon 3, we are getting 1 in the calculator, which means that the values of a and b, which is 1 upon 2 and 1 upon 3 pi respectively, these are the correct values for a and b. In part B, it says that another curve with the equation y equals to f of x has a single stationary point at the point PQ, where P and Q are constants. This curve is transformed to a curve with the equation y equals to minus 3f into 1 upon 4x bracket x plus 8. We have to find for the transformed curve, the coordinates of the stationary point, giving our answer in terms of P and Q. Now, to understand this, what we can do is first, let's assume that for the original function, the coordinates of the stationary points, let's make a simple curve, and let's say that this point was the stationary point and this was with coordinates p comma q. Now it is transformed to this particular function. Now to find the coordinates of the stationary point of this function, what we must understand is what these values represent. So minus 3, 1 upon 4 and x plus 8. So what we can do first is we can write this as minus 3 f of, we can write it as 1 upon 4x plus 1 upon 4 into 8. So that will become a 2. Now going step by step. So let's say if we have a function f of x, and now it has become, let's say, a function a into f of x, that basically represents a stretch in the y direction, and the stretch factor in this case will be a. In our question, the whole function is multiplying by minus 3, which means that the graph will basically be stretched in the y direction with a scale factor of minus 3. So the x value, which is the p coordinate, will remain the same, and only the y value that will basically multiply by minus 3. So after a stretch of minus 3 in the y direction, in this case, the coordinates will now become p and minus 3q. And then moving on to understand what does 1 upon 4x plus 2 means. So if we have a function f of x, and it now becomes f into a of x. Now this represents a stretch in the x direction, and this will have a scale factor of 1 upon a. So there's a slight difference with stretching in the x and the y direction. If it is f into a of x, the scale factor is taken as 1 upon a. Now in this case, as we have 1 upon 4x, it means that the scale factor will be positive 4. So after a stretch of scale factor 4 in the x direction, as 1 upon 4x would mean it has been stretched 4 times in the x direction. So the x coordinate will multiply by 4 and the y coordinate will remain as it is. So this p coordinate will now become 4p and the y coordinate will remain as it is. So this will be 4p comma minus 3q. And finally, this plus 2 basically represents a translation. So let's say if we have f of x, and now it becomes f of x plus a. That means a translation in the x direction, and the translation vector would be 0 and 2. Or, sorry, it will be 2 and 0. Or if it is a plus a, that would mean a minus a units in the x direction and 0 units in the y direction. So from this plus 2, we can see that this will basically move negative 2 units in the x direction. So this will become 4p, and this p will become p minus 2, as this x value is basically is changed by a unit. So in this case, the x value is changed by the by minus 2 units. So this will become, and this will not be a plus 2, this will be a minus 2 up here. We write a positive sign over here, but this basically represents a translation of negative 2 units. So this will be written as 4 into p minus 2, and this will remain as minus 3 cube. So the final answer, we can write it as 4p minus 8 and comma minus 3 cube. So we just have to be careful with one thing, and that is, if there's a plus 2 over here, that means that the x unit will be translated towards the left, or negative 2 units in the x direction. So this x value, which was p over here, that is basically translated 2 units in the x direction, and multiplying it by 4, that will become 4p minus 8. Now, we have to be careful about one more thing that I forgot to mention, and that is that whenever we are doing transformation in the x direction, so we always do the addition sign first, which means that we do translation first and then the stretch. So there's a small correction over here. So we had p comma minus 3 cube. Initially we'll have a translation and then a stretch. So this will first become p minus 2 comma minus 3 cube. So translation will happen first and then it will stretch. So this whole x value will multiply by 4, which will become 4 into p minus 2 comma minus 3 cube. And finally, we can write the answer as 4p minus 8 comma minus 3 cube. And if you're doing a transformation in the y direction, in that case, stretch is applied first and then translation. But if you're doing transformation in the x direction, in this case, translation is applied first and then the stretch. So the final answer will be 4p minus 8 and minus 3 cube. In question 9, a curve has equation y equals to 2x power half minus 1. In part A, we have to find the equation of the normal to the curve at the point A, 4, 3, giving your answer in the form y equals to mx plus c. Now, to find the equation of the curve, of the normal to the curve, first we'll have to find the gradient of the tangent. As to find the equation, we need the gradient and a point on the curve. So we already have a point. To find the gradient, first we'll find the dy dx. So that will become 1 upon 2 into 2. So that will multiply by 2 the coefficient, and the power of x will decrease by 1. So that will become minus 1 upon 2. 2 and 2 will cancel. So we'll only have x power minus 1 upon 2, which can be written as 1 upon x to the power half. Now, substituting x is equals to 4. So this will become 1 upon 4 into 1 upon 2, which is equals to 1 upon 2. Now, as the gradient of the tangent is 1 upon 2, it means that the gradient of the normal, that will be a negative reciprocal, which will be equals to minus 2. Now, once we have the gradient, we have a point on the curve. To make the equation of the normal, we use the formula y minus y1 is equals to m into x minus x1. So y1 is 3. This will be y minus 3 is equals to minus 2 into x minus 4. Expanding the bracket, we'll get y is equals to minus 2x. This will become plus 8, and minus 3 will add over here. So the final answer will be y is equals to minus 2x plus 11. In part B, it says the point is moving along the curve in such a way that at A, the rate of increase of x coordinate is 3 centimeter per second. We have to find the rate of increase of the y coordinate at A. Now, the rate of change basically is given by the formula dy by dt is equals to dy by dx multiplied by dx by dt. Now, in this question, we already have the rate of change of x, which is dx by dt, and that is 3. The dy dx at point A we found in the previous part, that was 1 upon 2. So dy by dt will be is equals to the dy dx at A, that was 1 upon 2, and dx by dt, which is 3. So the final answer will become 3 upon 2 centimeter per second, or we can just leave the answer as 3 upon 2. So the final answer will be 3 upon 2. In part C, it says at point A, the movement suddenly changes direction and speed and moves down the normal in such a way that the rate of decrease of y is constant at 5. As the point moves down the normal, we have to find the rate of change of its grade, of its x coordinate. So again, we'll be using the formula dy by dt is equals to dy by dx multiplied by dx by dt. So in this question, we have the dy by dt. We have to find the dx by dt, which is the rate of change of x coordinate. And to do that, we'll have to first find the dy by dx. Now, this basically is the gradient of the tangent. So dy by dt in this question is given as 5. And to find the gradient of the normal, as now it is moving down the normal in such a way that the rate of decrease of the y coordinate is constant at 5 centimeter per second. So we'll have to take the gradient of the normal over here. So the gradient of the normal was minus 2. And we have to be careful about one more thing, and that is it is giving the rate of decrease of y, which means that this will be taken as minus 5 into dx by dt. So the gradient of the tangent was 1 upon 2, which means that the gradient, the dy dx, or sorry, the gradient of the normal will be a negative reciprocal, which will be minus 2. So minus 5 divided by minus 2, that will become 5 upon 2. So the rate of change of the x coordinate will become 5 upon 2. And this negative sign is because in the question it says that y is decreasing at a rate. So that means it will become negative. In question 10, the diagram shows points A, B, and C lying on a circle with center O. So this is a center, and A, B, and C are lying on the circle and radius R. Angle AOB is 2.8 radians. The shaded region is bounded by 2 arcs. The upper arc is a part of the circle with center O and radius R. The lower arc, so this upper arc has a center O and radius R. The lower arc, which means that this part has a center C and radius of R. In part A, we have to find this angle ACO in radians. So ACO is this angle. Now to find this angle, there are multiple ways we can go about this. We can use the circle property over here, which means that if this is 2.8 radians, this complete angle will be half of 2.8, as angle at center is twice the angle circumference. So as angle ACB is equals to, so ACB will be half of 2.8, which is 1.4 radians. And as this is R and this will also be R, and this is R, so which means that these two angles will be equal. So angle ACO will be is equals to 0.7 or half of 1.4, so 0.7 radians. In part B, we have to find R, so capital R in terms of small r. Now we already have this angle as 0.7, which means as both of them are radiuses, this is an isosceles triangle. This will also be 0.7. So this will be taken as pi minus 0.7 plus 0.7. So that will become 1.4. So we can apply cosine rule to the triangle AOC. So we can write it as r squared will be is equals to r squared plus r squared minus 2 into r, and the angle is cos of, so that will become pi minus 1.4. Simplifying this, we'll get r squared. This will become 2r squared minus, now substituting cos of pi minus 1.4 in the calculator and keeping our calculator in radian mode. So multiplying it by 2, we'll get 0.33. So this will be a minus 0.33. So this will become a plus, and this will become 2r squared plus, multiplying 2 by cos of pi minus 1.4, we'll get 0.3399. So this will become 0.3399 r squared. Adding these two, so we'll get r squared will be equals to 2.3399 r squared. Taking the square root, so r will be equals to the square root of 2.3399 r squared. For r squared, the square root will cancel, and the square of 2.3399. So substituting this in the calculator, that will be equals to 1.5296 r. So giving it to three significant figures, the value of r, capital R, will be 1.53, and then small r. In part C, we have to find the area of the shaded region in terms of R. Now, to find the area of the shaded region, what we can do is first we can find the area of the sector AOB. So we can shade it up here. We can in the first step, we'll find the area of this complete sector. The radius is R and the angle is 2.8. So in the first step, finding the area of sector AOB, the area of a sector is given by the formula half R squared theta. The value of R, the radius is R, and the value of theta was given as 2.8. So this will become half into 2.8 R squared. Simplifying this, we'll get 1.4 R squared. Now, to find the area of the shaded region, we need the area of this part, so we can subtract it from the total area. Now, to find the area of this part, first we can find the area of the sector with center C and radius, which is a capital R. So this total angle was 1.4 radians over here, and the radius is R. So first we can find this total area and then subtract the area of these two triangles. So finding the area of this sector is ACB. Now finding the area of sector ACB. Again, we'll use the formula half R squared theta. In this case, the radius is capital R and the angle is 1.4 radians. Now, in place of R, we already have a substitution. R is 1.53 small r. So this will be taken as 1.53 R whole squared into 1.4. Now, substituting this in the calculator, we'll get 1.53 whole squared and then multiplying it by 1.4. That will be equals to 3.2776, and then dividing this by 2. So dividing the answer by 2, we'll get 1.638. So this will become 1.638 R squared. Now we'll have to subtract the area of the two triangles from this. So we'll be able to get the small area of the small region. Now the area of a triangle, we can use the formula half AB sine C. The value of the length is R and R, and the angle we can take as pi minus 1.4. So area of triangle, and we can name the triangle AOC, and it will be the same as OCB. So the area of triangle AOC, we use the formula half AB sine C. The two lengths will be R and R, so that will become half into R, and the angle will be sine of, and this angle we found in the previous part. So this was pi minus 1.4. Now substituting pi minus 1.4 in the calculator. So sine of pi minus 1.4, and we'll have to make sure the calculator is in radian mode. So this will become, and then we divide the answer by 2. So that will be equal to 0.4927. So we'll have 0.4927 R squared. And as there are two triangles, so we'll multiply this answer by 2. So the area of two triangles, that will be 2 multiplied by 0.4927 R squared. And that will be equals to, so multiplying this answer by 2, we'll get 0.985. So this will become 0.985 R squared. Now subtracting this from the area of the sector ACB. So the area of, so we can call this part as area of small segment AOB. So we can write it as area of segment AOB. The area of the sector was 1.638 R squared, and we'll subtract the area of the two triangles, which was 0.985 R squared. So that will be equals to 1.638 minus 0.985, which is equal to 0.653 R squared. Now, once we have this area, all we have to do is subtract it from the total area of the sector AOB, which was 1.4 R squared. So the shaded region will have an area that will be equals to the area of the sector AOB, which is 1.4 R squared, and we'll subtract it from this area of the small segment, which has an area of 0.653 R squared. So 1.4 minus 0.653, that is equal to 0.747 R squared. So the area of the shaded region in terms of R will be 0.747 R squared. Question 11, the diagram shows part of the curve with the equation y equals to x plus 2 upon x minus 1 whole squared. The lines x1 and x2 intersect the curve at P and Q, and R is a stationary point on the curve. In part A, we have to verify that the x coordinate of R is 3 upon 2 and then find the y coordinate. So as R is a stationary point, it means that at that point, the dy dx will be equal to 0. First, we can write the equation as x plus 2 into 2x minus 1 to the power minus 2. Finding the dy dx, that will be equals to, so differentiating x, that becomes 1, minus 2 into 2, that is minus 2, into 2x minus 1, and we'll decrease the power by 1, so that will become minus 3. And we also multiply, so first we multiply this minus 2 by this coefficient, so that will become a minus 4, and decreasing it by 1, so that will become minus 3. And we also multiply it with the derivative of 2x minus 1, which will be 2. So the dy dx will be 1 minus 4 into 2x minus 1 to the power minus 3. Now, as R is a stationary point, which means if the x coordinate is 3 upon 2, if we substitute it over here, the dy dx should come out equals to 0. So to verify that, what we'll do is, in place of x, we'll substitute 1 upon 3 upon 2 minus 1 to the power minus 3. 2 and 2 will cancel out. So this will become 1 minus 4 into 3 minus 1. So 3 minus 1 is 2 to the power minus 3. So that will become 1 minus, and this was a 2 into, so yes, x value is 3 upon 2. So this will become 4 upon 2 cube. So 2 cube is 8. That becomes 1 minus 4 upon 8, but that will become 1 minus 1 upon 2, which is 1 upon 2. So the dy dx should have come out as equals to 0. So just a moment, let's quickly revisit the differentiation. We multiply minus 2 by 2, that becomes minus 4. And we forgot this 2 over here. Okay. So this would have been 1 minus 8 upon 2x minus 1 to the power minus 3. So now substituting x is equals to 3 upon 2, we'll get 3 upon 2 minus 1 to the power positive 3. And as we brought it in the denominator, this will be taken as positive 3. So 2 and 2 will cancel out. 3 minus 1 is 2. So this will become 1 minus 8 upon 2 cube. 2 cube is 8. So that will become 8 upon 8, which is 1, which means the dy dx is coming out as 0. So this means that R is a stationary point. To find the y coordinate, we can just substitute the value of x, which is 3 upon 2, into the equation. So that will become y is equals to 3 upon 2 plus 2 upon 2 into 3 upon 2 minus 1 whole squared. So this will cancel out. 3 minus 1 is 2, and that will become 2 squared 4. So we'll get y is equals to 3 upon 2 plus 2 upon 4. Taking the LCM over here, so this will multiply by 2 and this will multiply by 2. That will become 6 plus 2, 8. So that will become 8 upon 4. And 8 upon 4, that will be is equals to positive 2. So the y coordinate will be is equals to positive 2. In part B, we have to find the exact value of the area of the shaded region. Now, to find the area of the shaded region, we'll first have to find the area under the line, that is PQ. And then we'll subtract the area under the curve with the equation y equals to x plus 2x minus 1 whole squared. Now, to find the area under the line PQ, we can either find the equation of the line and then integrate it, or we can find these y coordinates of P and Q and then find the area for trapezium. As x equals to 1 and x equals to 2 are vertical lines, so this will form a trapezium over here. Now, in the equation, which is y is equals to x plus 2 upon, the equation was y equals to x plus 2 upon 2x minus 1 whole squared. First, we can take the value of x as 1. So taking the value of x is equals to 1, we'll get y is equals to 1 plus 2 upon 2 into 1, 1, 1 minus 1, that will become 1 squared. So that will be is equals to positive 3. So we can say that the x coordinate of P will be positive 3. So x will be 1 and 3. So sorry, the y coordinate. And now taking x is equals to, so Q had x coordinate of 2. So for Q, the x coordinate is 2. So that will become y is equals to 2 plus 2 upon and that will become 2 times 2, 4. 4 minus 1 is 3. So that will become 2 upon 3 squared. So that will become 2 plus 2 upon 9. Taking the LCM, so 9 times 2 will become 18 plus 2, which will become 20 upon 9. Now, once we have the y coordinates, first we can find the area of trapezium over here. So the area of trapezium is given by the formula half into the height into the sum of parallel sides. So side 1 plus side 2. Now the height in this case will be from 1 till 2, that the height is 1. We know that the P has the y coordinate of P was 3. So this was 3 over here, and the y coordinate of Q was 20 upon 9. So the sum of parallel sides will be 3 plus 20 upon 9. So the area will be half into 1 into 3 plus 20 upon 9. Taking the LCM, so 9 3 the 27 plus 20, that will make it 47, and then 9 will multiply by 2. So the area under the line will be 47 upon 18, basically, which is the area of the trapezium. Now finding the area under the curve. So the area under curve will integrate the equation, and the limits will be 2 and 1 from P till Q. The equation is x plus 2 into 2x minus 1 to the power minus 2 dx. Now first integrating this, so when we integrate x, that becomes x squared upon 2. Integrating this this expression, so the power of 2x minus 1 increases by 1, that will become a minus 1. We'll divide it by the new power, which is minus 1, and also multiply it with the derivative of 2x minus 1, which is 2. So 2 and 2 will cancel out. We can rearrange this to write it as x squared upon 2 minus 1 upon, and we can bring this in the denominator and write it as a positive power. Once we have integrated, now we can substitute the limits. First, substituting x equals to 2. So we'll get 2 squared upon 2 minus 1 upon 2 into 2 minus 1. So that will become 2 times 2, 4 minus 1. So that will be 2. So that will become 2 into 2 minus 1. And then we'll subtract the lower limit from it to find the area. So the lower limit is 1. So this will become 1 upon 2 minus 1 upon 2 minus 1. So 4 upon 2, that will become a 2 minus 1 upon 4 minus 1, that is 3, minus 1 upon 2 minus 1. So this will become 3 times 2, 6. 6 minus 1 is 5 upon 3 minus, and this will become minus 1 upon 2. So 1 upon 2 minus 1 is a minus 1 upon 2. Simplifying this, we'll get 5 upon 3 plus 1 upon 2. Taking the LCM over here, we'll get 6. So this will multiply by 2, this will multiply by 2, this will multiply by 3, and this will multiply by 3. So we'll get 10 plus 3, which is 13 upon 6. Once we have the area under the curve, which is 13 upon 6, now we'll subtract it from the area under the line. So the area of the shaded region will be equals to the area under the line, that was 47 upon 18. So 47 upon 18 minus the area under the curve, which is 13 upon 6. Now taking the LCM again, well, we can obviously use a calculator, but just in case, so this will multiply by 3. So this will multiply by 3, 47 minus 39. So that the final answer will become 8 upon 18. And simplifying this, we can write the final answer for the shaded region as 4 upon 9.